Okay, I thought I'd do some troubleshooting of what is going on with Zscaler app, Zscaler private access, and Zscaler internet access when I'm accessing an application. So I thought we'll start with first principles. Let's log into Zscaler app here. So obviously, if I was to deploy this, I'd probably send the domain credentials, and specifically what then cloud I'm on as well, rather than getting prompted here. But I get through all of this. This here is redirecting me to my identity provider and signing in. So the sign-in process there has all been Kerberos authentication to the identity provider. It is the same identity provider. And I've previously shown how to look at the SAML request. So if I go ahead and look here and do a Kerberos list, K-list, I can see that I got my Kerberos ticket 319, and authenticated to the ADFS server and authenticated properly and got the token. So all well and good during the sign-in process. I'm going to sudo to root because I'm interested in looking at the logs, var logs, Zscaler here. And we can see we've got all of our logs here in terms of how I joined the service, things like that. The tunnel log here is the one that we're pretty interested in. If we go through this, this will actually tell me everything that I'm interested in about the enrollment. Was it able to get to the different parts of Zscaler, the mobile portal? We do need to get to both Zscaler net to understand which cloud I'm on, but also to be able to get to the services on Zscaler 2. These things are necessary for me to be able to resolve the internet. And therefore be able to connect to Zscaler. So we could sit here and we could go through all of these settings. We can see we've got the proxy settings that have come from Zscaler Internet Access and the pack file that I have configured there. We can see the detail about being able to connect and being authenticated to Zscaler private access. So lots of things we could just sit and run through all of this. We can read the pack files and everything that are downloaded. But it's probably not worth just going through each of these in turn because there's a lot of data, and in a debug mode, the logs do contain an awful lot of information. But let's go ahead and take a look at an application. So I've got my Apache server here defined. And it's currently said, well, it's running in my AWS and it's running in my data center, and Zscaler is going to pick up both of those to decide which one is the right one and the most performant one for me to connect to. Well, my physical data center is kind of where I am today, and AWS is actually running a connector, and my instance is over in Oregon. So I should choose the data center over any of them. So if I go in here and I go to my Apache server, as luck would have it, it's not running. Let's go ahead and find out why that hasn't happened. And I can tell you exactly why. It's HTTPS. There we go. Okay, so it's picked up the data center version of my Apache web server. It's available. If we go ahead and come back to Zscaler Private Access and look in the diagnostics flow, and specifically I'm interested in the last hour, more or less, we see 2 application accesses. And this gives me a lot of detail around what's going on. It tells me that the user is connected. Here's my source IP address. I'm in Milton Keynes. It knows that I went through a certain IDP to authenticate, which rules applied policy. The policy was called client access, that it granted access. The request was successful. we saw 428 bytes transferred. We know the Zen, and we know how long the Zen took to process the policy, how many bytes were received, and all of that kind of stuff. And then we know where the connector is. We know the connector was using this provisioning key, the real IP address of the connector, that I'm in Stony Stratford, which is actually just outside Milton Keynes. Gives me all the information I need around the transaction. Of course, if I want to I can view the raw log data, which gives me everything that would be fed to my LSS server. And if I'm logging a support ticket, taking this data and providing it to the support team gives them everything they need to know about the transaction that they can then look up, because every one of these log lines is unique and tells me what was going on. So, good tidbit. If you have a support ticket that you want to raise about a transaction, getting this log data and providing it to the support team will give them everything that they need to know about the application and the failed transaction or the issues that you're having. It has all my username information and everything in there as well. It is, of course, important that we understand what the application being accessed is. Logging a support ticket saying web server not available doesn't particularly help them when they don't know what the web server is, what the FQDN is, or anything like that. So as much detail as we can have here is necessary. So I can see which the transaction is going, and then perhaps I'm not interested in sending it to my data center version. Maybe I want to take that offline and I want to quiesce it, or quite possibly there's an issue with that, or it's more performant to send it to the one in AWS. And of course I can control that here just by changing my server groups. And I can say, well, I no longer want to send it to the data center. Let's take that out and just send it to AWS. And on the very next refresh, provided all things are equal, it should now spring up to the one that's running in AWS, ever so slightly different website. So I can steer traffic in different directions. Let's go back and look at those diagnostics logs. Now we can see that the transaction went over to AWS. Now, interesting things here, you notice that the transaction is still going through the same Zen. And that is because the user's connection is always to their closest Zen. And we will keep them persistent on that until there is an issue that takes them off that. Now, what we'll also see when you look at these two transactions, we're now going from the physical data center connector to the data center to the connector that's in AWS. And we know this one is, it says Brothers US, but it's actually somewhere out in Oregon. So we know we've bounced from one connector to another connector, but we're still going through the same data center. So let's understand what's going on there. If we have a look at the connectors, I've got two connectors. In fact, we're actually looking at this one. This connector here is connected outbound. It has its control connection to the UK node 8175, and the AWS connector is connected to Oregon 8221. Okay, so what does that actually mean? Well, if we look at 8175 and go back to these diagnostics logs, it's a different Zen entirely to the Zen the traffic passed through. And that invariably will be the case. A connector will have a control connection, which you will see identified under the connectors tab. And that is the connection that it will have a persistency to say, hey, I'm available, I'm ready to participate in transactions, tell me what to do. And the user will have their connection to their closest Zen. And when a user makes a request for an application and we use the control connection to talk to the connectors to say, are you able to see this application? Are you ready to participate in this communication? That control connection will then signal the Zen once we've identified which Zen or which connector group, and therefore which Zen within that connector group is going to participate in the communication. And it'll then signal that connector to establish a new connection outbound to the Zen that the user is connected to. So what you'd expect to see, connectors have lots of connections outbound to all of the Zens where users are connected to, and users will have a single connection essentially to the Zen that is geographically close to them. And it's that Zen that is geographically close to the user that stitches those two connections together. Okay, so we've got all of that information. We know that the connection is passing through. We've passed some transactions through Zscaler Private Access. Let's see if we can understand what's going on within the transaction logs. So I'm just going to come over to my text editor because it's easier for me to remember things like that. Okay, so we're just going to grep through the logs and we're going to say, okay, tell me about anything which where we saw a broker redirect, and the broker redirect is the initial connection from the client to the Zen and says, hey, now give me tell me which is the closest Zen for me to connect to for my control connection. And then we're also interested in the authentication that we acknowledged and we were actually connected through to that Zen. And of course, we've only just restarted Zscaler app and logged in, so we don't see a lot of this. But what we can see is the user connected to the redirect broker, or Zen, and the Zen said, hey, the closest ones for you to connect to are broker1.lon3.prod.zpath.net, and the backup one is broker2.lon3.prod.zpath.net. So prod.zpath.net is the production Zscaler Private Access Cloud. Lon3 is the Zscaler physical London 3 data center, and then we've got two Zens in each of there. The client then picked one, and through picking that one, it decided broker 1 was the one it wanted to connect to, and that was the one that we've then got the connection to. So fantastic. Control connections up. Let's see if we can figure out how we acknowledge the transactions that went through. One way to do that, if we start by looking at these transactions here, you'll notice that we have a transaction ID within each request. So we could grep for that in star.log, and we can see that the transaction was requested. And what we'll just do is we'll say minus B4 minus A3. We'll just have a quick look for those transactions, and we can see that there were this request here actually had a tag ID of 19. So the tag is the individual transaction ID. So we've got a transaction ID and we've got a microtunnel ID for that transaction. So we can now go and grep for tag ID 19 through star.log. And that will give us all the information that we're interested in around this. So we've got, here we can see the tag ID 19, here was the request apache.welshgeek.net, we got given a microtunnel ID, and then we got a bunch of traffic sent through for that request, and then we can see the tunnel ended, and we closed down the connection, and then the connection closed at the end. Now, very simple, very easy log to find. We know exactly what we're looking for. Invariably, we won't see that amount of won't find something as simple as this to find. We're more invariably looking for a needle in a haystack. And generally, we're not looking for connections that have succeeded. We're looking for errors and things that have caused problems. But if we can think about, finding the application name, We understand the microtunnel IDs that are provided in the UI. We can stream the logs to our log streaming server, our SIM, and search for these applications. Getting the client-side logs and getting the logs from the diagnostics portal, we can match these two up and start to look for transactions that might be problematic and understand why the traffic has failed. Okay, so let's have a think about actually how that transaction looks from a client side. So, interestingly, if I do an NS lookup on a Mac for apache.welshgeek.net, I get a 192.168.1.11 address back. Or I might be getting an X domain off network, which is not really the way we want to go. And the reason for this is that NSLOOKUP or dig apache.welshgeek.net kind of bypasses the DNS resolver that Zscaler Private Access implements to intercept that request on a Mac. The real way to do this is DNSSD, and what we're going to do is we're going to say, if we take a look at this, we've got -G, because we want to do an IPv4 lookup, and we can say apache.welshgeek.net, and that will mean that it'll actually get intercepted. We can see the request, and it's 164.1.2. So we know the actual IP address the user went to. Then we could do something like a curl-v http apache.welshgeek.net to get the raw traffic. And again, here we'll see it trying to connect to 164.1.2. We can see the requests going through, and we can see the responses coming through. So really, coming to a command line is often an easy way for you to find out what is going on with the request and where that traffic is going to client side, and making sure that it's going correctly. Alternatively, let's pick a different host, because what we tend to see a lot of is things that might be doing more enterprise authentication, and Kerberos is one that we will see a lot of, and it's worth understanding what's going on. So I'm going to come out of my root, and what I'm actually going to do is kdestroy -a, destroy all my Kerberos tickets. I'm going to quickly lock my machine and unlock it again. And what that'll do is force the machine to go off and get a new Kerberos ticket. So let's take a look at what's going on with this. And I like to start with Wireshark for my captures. So we'll load up Wireshark, and we'll come into Zscaler app, and we will start the packet capture here. So what I'm going to do is I'm going to go curl https adfs.welshgeek.net adfs ls WIA. So WIA is the Windows Integrated Authentication. And I'm going to tell it to use negotiate authentication, so Kerberos. I'm going to tell it to just use my current username. And we'll see a couple of things that went on here. It ended up, what I should have done is a -v. We would have seen the traffic going through. You'll have seen that it sent the negotiate authentication method. It got all of the Kerberos tickets and presented them to the server, and we can see the Kerberos tickets went through. So let's go ahead and open up those files, and we can see that we've got a packet capture now generated here. In fact, I need to stop that packet capture. Make sure it's there. There we go. And we're just going to load that up into Wireshark. Okay. So now we've got this packet capture. Now, the interesting things that we know are we know that -g v4 dc2.welsh.net is 1.3, and we know that my Apache server, the ADFS server is 1.1, and so we can start to look through this packet capture, and really what we're interested in first off is DNS. So here are the DNS requests and responses. We can see that the ADFS 1.1. The other interesting things that you will see that we should see in here will be things around DNS for Kerberos and things like that. But what we're interested in now is those IP addresses 100.64.00/16. So we can see these requests. So here is the DNS to start off with. Here is the client request in the traffic. Now bear in mind that because we're using the root mode adapter and an older version of, or a Zscaler app 1515, we're going to see some duplication and some port mangling that's going on. The server name, as you'd expect, is the ADFS server, and we know that the Kerberos server was going to challenge me for authentication. And so it's worth looking then at these Kerberos ticketing requests. And we know that the service name is the ADFS server, and we got the reply back from the ticketing server 1.3, which is the domain controller that tells me that here's the ticket that's provided. So we can marry up all of those transactions back through to Zscaler Private Access. What we can also do, we go back to the Zscaler logs. We could do something like grep-msi port.star88, because we know Kerberos is port 88, and we can see that the ticketing requests here, we've got a couple of different tags that have come through for that. We can now trace that grep-msi tag underscore ID .star33. So we're looking for that tag. We now know what the microtunnel ID is. So we could then take that, for example, and put that in as a filter, where we could say connection ID is this one. Contains. Let's just figure out why it didn't. Why it didn't pick that one up. It should have. There we go. So we can say contains this, and we find the connection ID, and we know that it's then a I picked the wrong connection ID, that's why. Tag 34. What we really want is this one, connection ID 33, and let's do that. Okay, so now I can see my TCP port 88 connection ID. I can see that the connection went through. It went through the Zen in London, egressed here, port 88, and I can see all of those transactions passing through. So hope that's helpful. Gives you some insight into how to read some of the logs, how to diagnose some of the problems, understand a bit about enterprise authentication and passing through Zscaler private access.